Let's go ahead and begin today's webinar. I'd like to introduce Paul Marca. He is the Executive Director from the Stanford Center for Professional Development. Welcome, Paul.
Thank you, Stacy. I appreciate it. And it's my pleasure to be here with you today. The Stanford Center for Professional Development has been delivering education to people in the world of work for many, many years, since 1969, and online since 1997. We're particularly pleased to be hosting this webinar and also this course offered by Professor Jo Boaler, mathematics education here at Stanford. And I have to tell you that I have a secret mission as to why I'm so excited about this course. I have 3 small children, twins, 12 years old, and a 10-year-old who desperately need to like math. And currently the level of instruction is not good nor inspiring. Dr. Jo Boaler is a professor of mathematics education here at Stanford University, and it's our pleasure to welcome her and the collaboration also with the Vice Provost for Online Learning here at Stanford University. They have built the course, so we are extending the course out to as many of those of you who can attend both this session, and we're now queuing up another offer in August, slated for offer number 2. Dr. Boaler is here at Stanford in the Graduate School of Education, also co-founder of UCubed, whose mission it is to harness the power of new technologies to transform mathematics education in the U.S. and beyond, in order to give teachers and parents the resources and ideas they need to inspire and excite students about mathematics. Again, why I'm so interested in this webinar and the course. She's also editor of the research commentary section of the Journal of Research in Mathematics Education and an analyst for the PISA testing in the OECD, and really the author and creator of the first MOOC on mathematics in teaching and learning. In times past, she has been the Marie Curie Professor of Mathematics Education in England, a mathematics teacher in the London Comprehensive Schools, and a lecturer and researcher at King's College London. Her PhD won a National Award for Education and Research in the UK, and her books, a number of books, particularly her latest, What's Math Got to Do with It in 2009, and The Elephant in the Classroom in 2010, published by Souvenir Press in the UK, both aim to increase public understanding of the importance of good mathematics teaching. She serves as an advisor to several Silicon Valley companies, including the one she has nurtured, UCubed, and has been a frequent presenter to the White House in girls and the STEM issues. So with that, I want to turn the floor over to Professor Jo Boaler. Jo, welcome.
Thank you, Paul. Hello, everybody. Good afternoon, good evening, good morning, whatever time we're in. So first of all, I'd just like to say hello and welcome. Some of you I know will have probably taken my online course last summer, and it's really good to see you again if that's the case. Some of you may not have done, and so I've pitched this really today to some of it will be review for those of you who took it, some of it will be new, and if you didn't take it, a lot of it will be new, I guess. But it's been a very interesting year since the online course that I taught last summer. I've been working very closely in one particular school district, Vista Unified, and I'll share some of that. I launched UCubed, the non-profit site, at the end of my online course because so many people wanted to keep getting the ideas, and I'll tell you more about that later. I was in the White House last week, which was very exciting. I've just finished the online MOOC course for students, which I'll show you a bit later, and as Paul mentioned, I've been working with PISA. So I'm really excited and happy that we're re-releasing the parent and teacher course, and later on I'll show you some of the sort of impact of that, which was really great. I've also been doing lots of parent meetings, and what I want to do is share a video with you soon that I'm making to help for parents who are sort of not understanding the math changes that are needed. And I wanted to mention as well, I've made a handout that every reference I give in this session and all of the links I give are on that handout, so you can go to the website later if you want. So I want to start actually with a question for you, and that is it would really help me in talking to you if I know who did actually take the online course last summer. So perhaps you could answer the poll. And if you took any of it, please say yes. And if you didn't take any of it, say no. And then also I have a question about whether you're a teacher or a parent or work in some other way. So if you could answer that poll now, that would be great. Thank you. So I think we're going to get the answers to the polls pretty immediately. So we can all have a look at those, I think. Let's have a look. All right, so pretty almost evenly split. So about a third of the people did take the online class. That was interesting, and really evenly split amongst the different levels of school. So great, I love that. We have all different grade levels. And some parents as well. So I'm going to begin. I thought I'd share with you a picture I took in the White House last week. So you're probably thinking now, did I really take that photograph in the White House? I did really take that photograph in the White House, but it was cheating a little because the president was in China at the time, and that's actually a photograph of a photograph in the White House, but I think it's a really nice photo, so I thought I'd share that with you. So anyway, I'm going to begin today by briefly, just for 5 minutes, going through the sort of basic ideas behind the changes that I think we need to make, which for some of you will be a review. And then after that, I'm going to get into my favorite teaching strategies for you. So the big idea that I've been talking a lot about is this thing that we suffer from in the US, which I describe to people as the elephant in the classroom. And you know the expression, the elephant in the room, which refers to an idea that everybody's thinking about but nobody talks about. And I argue that there's a big elephant standing in most math classrooms in the US and in other countries. And that is the idea that only some kids can be good at math. Teachers believe that, parents believe it, and students believe it. And that single idea is at the root of a lot of the underachievement in the US. And I think as math teachers, we have to deal with this myth that's out there, that being good at math is some kind of a gift, and that some people are naturally good at math, some are not. So we have decades now of research, really solid research, that shows that is completely false. You're not born with a math gift. Nobody's born with that. And everybody, in fact, can achieve at high levels in school. It's to do with the experiences people have from birth. And it's also really important how kids think about this, the ideas they have about their own ability and their own potential. So you probably know Carol Dweck released a book which was a New York Times bestseller, in which she summarized her research from a number of years, which shows that people have one of two mindsets. So if you have a growth mindset, you believe that the more work you do, the smarter you get. But if you have a fixed mindset, you believe that you're either smart or you're not. And it turns out about half of kids have a fixed mindset in mathematics. And that mindset really harms their learning. So we also know that these different mindsets go along with different behaviors. So kids with a growth mindset are more persistent, they're willing to learn from mistakes, they're very determined to keep going, and they're encouraged by each other's success. Kids with a fixed mindset are those kids you probably know in your classroom where you give them some challenging math work to do, and they'll immediately say, I can't do this, I need help. We know that fixed mindset thinking affects students from across the achievement spectrum, and in fact, high-achieving girls are some of the worst hit by fixed mindset beliefs. And we also know that praise is really important in giving these different mindsets. And the way that many kids in the US have a fixed mindset is because as parents in the US, we often praise kids for being smart. So when they do something good, we say, you're really smart. And what we now know kids process about this is at first they think, oh good, I'm really smart, but then when they fail, and they will later, they think, oh, I'm not so smart, and it starts to set up this fixed ideas. In Carol's latest research, they found that the praise given to babies between the age of 0 and 3 predicts their mindset 5 years later. So very important around the way we speak to kids, and this graph just shows you students were given a survey at the beginning of 7th grade to see which mindset they had. and the line that goes on the bottom is the kids with a fixed mindset, and they just followed kids over the next year or two to look at their achievement, and those with a growth mindset are the ones that go onwards and upwards. So we also know that mindset has very important implications for equity. Mindset interventions have the greatest impact for students of color and for girls. And as I said, fixed mindset thinking is much more prevalent amongst high-achieving girls. And in fact, the reason I was at the White House was I was reporting to the Council on Women and Girls about girls in STEM, and I talked about some of this, the importance of mindset for girls. And the paper I handed out at the White House is on U-Cubed, and you can see that in the handout. So, as was mentioned, I've been working with the PISA team over the last few months, which is really exciting. You probably know the PISA team give international math surveys every 4 years, but they also collect a lot of data on students' ideas about math and themselves. And so this data hasn't really been released a lot yet. We're writing some things up, but it turns out that the mindset kids have are hugely important, and also the way they approach math is really important, as we all know. And in fact, the kids who say that they memorize, so when they approach math, their approach is to try and remember lots of things, are the lowest achieving kids in the world. The kids who come into math saying they're thinking about the big ideas are the highest achievers. And what we can see from this graph is the huge difference for the kids with a fixed and a growth mindset. So the kids with a growth mindset are the highest achieving kids. This is from 13 million 15-year-olds. And those with the highest achievement in the world are those with a growth mindset and that use these good strategies, the sort of strategies that I discuss and highlight in the teacher course. So I'm going to talk about 5 key strategies today, and they fall around these 4 big things that are all really important to teachers around how we group, how we assess and grade, the tasks we give, and what we do with mistakes. So it's my view that the 2 biggest changes we need to make in US mathematics education, the first one is we have to get students believing that they can achieve at the highest levels of mathematics, which many don't now. And then we also have to engage them actively with mathematics. And we know that when we get kids problem solving, talking about mathematics, reasoning through problems, they achieve at higher levels. So they're really important, and particularly the role of mathematical discussions. So we know that, contrary to common belief that the best way to study math is to be alone with a book, we know that when kids talk about math, it gives them access to a deeper level of understanding. But there's another reason to have kids talk about math, and something that I'm talking to parents about when they're opposing the Common Core. So what I'm finding is a lot of parents, particularly of high-achieving kids, are saying, why should my child explain their methods? They can get the work right. Why are they having to explain their methods? And what I say to them is explaining methods is what in mathematical language we would call reasoning, is really the core of what mathematics is. So when a scientist proves something, they look at it in a number of different cases. But for mathematicians, they actually reason their way through to proof, and it's the core of the discipline. And I wrote an article about that, which appeared in The Atlantic last year, and if you have parents who are needing to understand both, and teachers too, the ways to change the way we think about kids and how to get rid of the stereotypes, and also the importance of reasoning, then you can find that article, and the link is in the handout. So I'm going to start off by talking about grouping. We know that discussion is really important, discussion in whole class discussions, small group discussions. But it's often derailed, as teachers know, through unequal participation. So what can happen often in group work is one student will do all the work, another one will be left out, somebody else chooses to check out, and that isn't the way good group work works. So I'm curious, and I'll put this in a poll in a minute, how many of you know about this, but an approach to group work that I've found to be associated with high achievement, as have other researchers, is one called complex instruction. So complex instruction starts from the basis that you have to make group work equal, and you have to counter status differences to do that. And they do it, and you can do this in any subject at any grade level by giving the students roles, by teaching a broader, what I would call multidimensional mathematics, by giving different messages about who can achieve. So the approach was designed by Rachel Lotan and Liz Cohen, and if you want to read more about it, there's a great book in it, Designing Group Work. The yellow one has been out for some years and is available now. They've actually just re-released the book, but if you want the re-released version, that's coming out in July, and that's on your sheet. But anyway, now I want to come up to my first strategy, which is something I've really come to love over the past year. So this is really new, but I'll tell you about that. But before I do, I'm curious about whether any of you have used the approach of complex instruction at any time. So there's a poll now coming up. Have you ever used the strategy of complex instruction when grouping kids? So I'll just wait and for a little while people answer that. Okay, so I think we're going to see, okay, so we have 16% of people have used it at some time, 62% have not used it, and 22% we don't know. So if you would like to learn more about that approach, then those books and also articles on YouTube will help you with that. But there's something particular they do inside complex instruction that I'm going to teach you. Before I do that, some other things we talked about in the course was the way we assess and grade kids. Obviously, the way kids get feedback on their work hugely impacts their mindset. And one of the things we talk about in the online course is how replacing grades with diagnostic comments is really a positive thing for students' engagement. So we tend to grade a lot in the US. In other countries, kids get a grade at the end of the year. And what we know is from studies is that when teachers stop grading altogether and give diagnostic comments telling kids what they need to do to improve, achievement really goes up. So, but I know as well, and from all the work I do with teachers, that particularly teachers in the US feel that their hands are tied and that they have to be grading a lot because the school administration requires it, parents require it, districts require it. So one of the things that I recommend for them is to switch the grading. So instead of grading always being on sort of how many answers are correct, actually grade on the participation you want to see in the classroom. And once you start grading on that, kids' participation drastically improves. So this leads me to my first strategy, which I'm really loving at the moment. So this is something called a participation quiz, and those of you who know complex instruction may know this strategy. So I taught this to the teachers I work with in Vista School District, and they did the participation quiz the first day with a group, and they tell me by the time the groups met for the second time, it had transformed the way kids worked in groups. So the way it works is students work in a group on some math work, and they are literally graded. The group is graded at the end of the lesson for their participation in the group work. So the teachers are actually looking for how they participate. Are they leaning in and talking to each other? Are they asking good questions? Are they working equally? So I'm going to take you through how to run a participation quiz. It would be much better if we could watch videos and talk about this in a PD session, but I'm hoping this will help to just try it once and see what happens. So this is how you run one. You just choose an orderly day of group work where kids are working on math tasks together, and then you tell kids they're going to get a grade for how they work in the group at the end of the lesson. And then it's very important you show students what you're looking for in their group work. So the example I'm going to show you, the teachers share with students, we're looking for these kind of interactions, and we're looking for this kind of mathematical work. Now, then you either get a piece of paper, or some teachers do it on the board publicly or on a whatever form of display. into sections for each group. So if you have 32 students and work in groups of 4, which complex instruction recommends, you might have 8 sections. And as students are working on their groups, teachers circulate the room just writing down comments inside the boxes for each group, how well they're working, any good questions that come up, and then at the end of the lesson they assign each group a grade. So the teachers I work with, I'm just pulling their slides that they've used for a participation quiz, just to give you an idea. But they showed to the students before these. So this is the mathematical slide. There's a lot on here. I'm not sure I would use as many, particularly for younger kids. You might want to highlight 2 things. But this shows you a full range of things, the sort of things you could put up here. But so they say we want you to be recognizing and describing patterns, justifying thinking using multiple representations, making connections between different approaches and representations, using words, arrows, numbers, and color coding to communicate ideas clearly, explain ideas clearly to team members and the teacher, ask questions to understand the thinking of other team members, ask questions that push the group to go deeper, and organize a presentation so that people outside the group can understand your group's thinking. And sort of the mantra of complex instruction that the teachers use with it is this message to kids: no one is good at all of these things, but everyone is good at something, and you need all of your group members to be successful. So these are the kind of mathematical things they're looking for. And then the teachers had very concrete thing, group behavior. We're looking for you to be leaning in and work in the middle of the table. So a nice strategy for group work is a sort of tip really, is to only have one work piece of paper. Because if kids have their own paper, they're very likely to pull off to the side and work on it. So one task paper, are they leaning in and working in the middle of the table? Is there equal air time? Are they sticking together? Are they listening to each other? Are they asking each other lots of questions and then following the team roles? So as a teacher, I might have a sheet something like this and walk around making notes on a clipboard, or as I said, I might have it at the front of the room. And I'm just going to share with you an example of one teacher's notes at the end of a participation quiz. So you can see they've graded the groups, but also at some points they've just said great discussion, working well together, building on each other's ideas. Sometimes there's a question written down that is a quote from the kids. Can anyone see a different way? You can see the bottom left-hand group weren't working so well together, talking about clothes, off task. So what happened with the teachers that I work with in Vista School District is they tried a participation quiz one day, and they told the kids we're going to be grading you on a group work. They went down making notes, and I guess the kids didn't really pay much attention to that. And at the end of the day, they gave them grades and talked about it. But what they said was the next time they did group work, the very next time, the kids' interactions in the groups had massively improved. So they're really loving using this as a group work strategy. So this is a quick overview, but I'm curious, and I put in another poll here to see. My question is, do you think you would try a participation quiz? One thing I can do is put up more detailed instructions on YouCubed if you would like. So maybe I'll just stop for a minute while you can fill that question out. Do you think you would try one of these? All right, so I think we have the results, and we'll just wait a little while, and we'll all have a look at what you might think about participation quizzes. All right, great. So lots of people are interested in trying. That's great. So I'd be really interested if you try it to hear what happens. So you could email me. I have a Twitter account. I'd love to know if you try these out, what happens over the next sort of times of doing group work. So my next thing I want to talk about a little bit is classroom math tasks. So in the Teacher online course, we spend quite a bit of time on tasks and thinking about what makes a really good task for students. I argue that it's very hard to have a growth mindset in math when all you work on in math class is a series of short closed questions that you either get right or wrong. So those kind of questions don't convey to kids that math is about learning. And in fact, we know that a lot of students actually don't think that they're in math class to learn. They think that they're there to perform, and they'll tell you that when they go into math class, what's important is to get questions right. So they're not so oriented around learning as much as performance. And this really came home to me recently when a colleague of mine, Rachel Lambert, told me her 6-year-old son came home one day and said he hadn't liked math class. And she said, why? You know, what happened? And he said, math is too much answer time and not enough learning time. So that's a really perceptive comment from a 6-year-old, but you know, you can see how kids get this impression that they go into math class and they're answering questions. So what I do in my work with teachers, and we talked about in the teaching course, is tasks need to give students the space inside them to learn something. If a task really is just answering a question, that doesn't really have space for learning. So I shared this framework we've developed for growth mindset tasks. They need to focus on learning and have opportunities to learn something inside them. So to do this, the main thing is to open up math tasks. And you can open them in different ways. You can have a task where you ask kids how they see it, and I'll show you an example in a minute. You can have tasks with multiple entry points, tasks that value different pathways and strategies, tasks that focus on sense-making rather than an answer. And we'll look at a little example. So this example comes from a wonderful teacher, Kathy Humphries, and is actually in a book of video cases of her teaching her 7th grade class. So the book's called Connecting Mathematical Ideas, but 1 divided by 2/3 could totally be a closed one-answer question that students just answer. But she opens it up by focusing on sense-making. So what she says to them is not get the answer to 1 divided by 2/3. She asks them for the answer and then asks the students how to make sense of their answer with a representation. So what you get from that is there are many different ways of seeing the problem, and students have different methods and different representations. So many of the kids in the class got the answer 6. You know, do something with 2 and 3, comes out with 6. But then they really struggled to make sense of that. So Kathy uses this in the classroom. I really like this, and it's really good for the Common Core. And it comes from a book by some English authors, actually, where they talk about telling students there's a 3-stage process, really 3 levels or 3 standards of a convincing argument. Now, kids need to be making convincing arguments with the new Common Core. And what they say is that the lowest standard is when you convince yourself. We're usually pretty easy to convince ourselves. The next level up is when you convince a friend, and the 3rd level up is when you convince a skeptic. Actually, in the book, they say convince an enemy, and Kathy changed it to a skeptic, I think. Anyway, she has asked the kids to be skeptics, and I did this actually just this past week with a group of teachers. It was great, and I said, okay, we really got to be skeptics. You've got to push any answer you get, any reasoning, to make sure it completely makes sense to you. Be very skeptical. How do you know that? Kids love being a skeptic. You can get them all to be skeptics with each other, and they take on that role really readily. But it's also really helpful in pushing other students to convince and reason, so very mathematical things too. So I wanted to tell you about a wonderful task that helps kids be more convincing. And in fact, I used this task just last week with the role of the skeptic, where some people had to convince others and the others were skeptics. So this isn't the whole task, but the whole task is on YouTube. And it comes from Mark Driscoll, and it's a book called Fostering Geometric Thinking. And it's a paper folding task. This is one of my favorites, and I think this is great for lots of age levels. So I'm only showing you a little extract of the whole task, but they start with a square piece of paper, and they have to do all these different constructions, and just one of them's up here. Construct another square with half of the area, but that's oriented differently from the one you constructed in 4. There's a whole list of questions. Explain how you know it has half of the area. So this is a great task. Kids actually have to make this and fold their square, and then they have to be really convincing that they know that this is a square. So what you see as they do this is they're pushed to be very precise, to be very mathematical, to use the right words, particularly if you have other people being skeptics. So I love that task. On UCubed, there's a high school unit, so there's 3 units on UCubed at the moment, one for elementary, one middle, and one high. The high school one actually is one we wrote here at Stanford, and it's over 100 pages of great activities. And this paper folding activity is one of them. It's on page 87. So if you want to go to that task, you can buy the book from Heinemann, and the link's there, and it's a great book. Or you can get the task in that way. So an example of something that I want to share with you now comes from a 5-week algebra class that I actually taught with my graduate students in summer school. So it was a summer school, 7th and 8th grade kids who are mainly underachieving, and our goal in teaching the class was to teach algebra as a problem-solving tool. And we drew from different places for our tasks, Ruth Parker, Mark Driscoll, some English schemes. But one of the things we did was we kept all of the tasks open, and we actually got amazing participation from the kids. My book, What's Math Got to Do with It, describes what happened in the summer school in more detail on the tasks. But we basically gave them a lot of algebraic pattern tasks. They hadn't learned algebra, and they learned algebra through that and did really well in algebra afterwards. And we kept the tasks open. So I wanted to share with one issue that teachers have is kids always work at different levels. They are at different achievement levels. They work at different speeds. And one thing I like to do in my own teaching with kids is always to have a strategy up my sleeve, which is to get any kids who finish to either extend the task they're given or ask a new question. So this happened a lot in summer school, and this is one example. We gave the kids this task, and there are 2 ways to give this task. Find the total number of blocks in a 100-block high staircase is the kind of traditional way of asking that question. The way I like to ask it, and you may have seen before, is asking people how the shape grows visually. And from there, they get to the 100-block question, but much more conceptually. But anyway, we asked, when kids finished, we just said, okay, you now, over to you. You come up with your own question. One of the boys who had got all Fs in math class came up with this lovely extension, which is much harder conceptually, where they were looking at staircases, and all the kids started doing this. So my strategy really around this is whenever you're working with short math questions, with long math questions, great strategy for kids is when they get to the end, just say to them, now over to you. You write a question and try and make it a hard question, and then have kids give their questions to each other. It involves kids in a much deeper way. It helps them with the mathematics. It helps them in all sorts of ways. So I really like that strategy. But so generally we know that when math tasks are more opened up for different ways of seeing, different pathways, different representations, the opportunities for learning and for developing a growth mindset are increased. So a couple of other things to share just before we finish. Not going to say much about speed, other than we do know that math should not be associated with speed, and the article you see there just came out in NCTM's journal and is also downloadable on UCubed about the damage caused by time tests. So just a mention of that. But what I want to finish on the last couple of strategies is I shared in the teacher class, and we spend a bit of time discussing how I teach these classes for teaching math for a growth mindset, and Carol Dweck came into the first one and said something which shocked all the math teachers, which was every time a student makes a mistake in math, a synapse fires. And actually we have new research evidence just from the past year that shows that when kids make a mistake in math, brain growth occurs. Electric stimuli fire in their brain, but when they get work correct, no brain growth happens. And they don't have to go back and correct the mistake, which a lot of people think. It's really the point of struggle that causes that brain growth. So this has huge implications for us, I think, as math teachers. It means we really want students making mistakes. Mistakes are when their brains are growing the most, but they need to feel safe in the environment to do that and know that mistakes are valued. really great for teachers just to start the year saying, I love mistakes. Mistakes are when your brains grow. I want to see mistakes. You'd be amazed how much that puts kids at ease mathematically. So here's my fourth strategy. This actually came from a teacher in the online class. So in the mistakes session, I asked people to design a sort of new way of handling mistakes in the classroom. And I'd love to know who the teacher was who suggested this. If you're listening, perhaps you could email me. But one of the teachers in the class submitted her idea, and she said this. She said at the start of classes now, she gets kids to scrumple up a piece of paper and throw it at the board with the feelings they have when they make a mistake. And then she gets them to unfold the paper and draw a little brain on it, and then just draw over in colour all the lines from the crumpled up paper. And that represents all the synaptic firing of making a mistake. And she gets kids to keep that to remind them. Another thing I loved comes from one of the teachers in Vista, Kim Hollowell, who took from the course all the messages that came from the course about the value of mistakes and other things. And she asked kids to design a picture of their own brains, and you can see there, or they were told about the parts of the brain that sort of see in black and white and colour. And so they each designed their own brain, and they put their favourite message on it. So it's a beautiful visual, and you can see some of their different messages the kids chose. Easy is a waste of time, I don't know this yet, embracing struggle, I can grow my math brain, lots of things. So a couple of things about the future just to finish off. I will be uploading on YouCubed within the next month. We just have funding for YouCubed, and so we're just finally putting lots of new stuff up there, and a video for parents explaining why high achievers need to be in classrooms with others and working on these ideas and other things. So look out for that. So the online class which some of you took is now re-released by Stanford. It actually was amazing last summer. It really surpassed all my expectations. 40,000 people registered, and at the end, 92% of people said they were very or extremely satisfied with the course. 95% said they would change their teaching as a result of the course, or ways of helping their own kids. And they did that. I had thousands of emails from people, great emails, detailing the changes they'd made and how it had changed their students. So the course is up again. Stanford is charging for it at this point. It's $125. You can take it and get a sort of certificate for your school. The schools, I hope, will pay for this, or districts. And we know that some districts will pay for teachers or give them salary advancement. So if you want to take the course, it's open now. You can go up and register. Also, we're releasing a student MOOC. So these are things to get the ideas straight to students. 6 short 15-minute sessions designed to improve students' relationships with math, give them a growth mindset. Features, my undergrads helped me present it. I'll show you a little bit. And that's designed for students of any age. The details of that are on the handout too. So in fact, I'm just going to show you a little minute clip from the student course that we have. More details, more details for that are on the handout. And then YouCubed is the non-profit site I started last year just to keep these ideas up for teachers. Has a number, and parents, has a number of sections on it, a section for parents, for teachers. There are different units on it, some videos, details of the MOOCs. If you sign up with your email for that, you'll get newsletters, and there's going to be a new really different, full of ideas site in the next month. So if you're signed up with your account through school and you want to get new ideas over the summer, you might want to sign up with a personal email. But if you go to the bottom of the site, it just asks you to give your name and to do a math problem. That's so they know you're not an alien. Somebody tweeted me and said they were glad it wasn't timed. It's not timed, but if you fill in your email, you'll get all those great things that are going to come up in the summer. And then we have a little clip of the teacher course too to show you, so you can get an idea of the sort of things we work on in the teacher course. So we're going to show you that now. All right, so we've had some questions come in. We'll just spend the last few moments on answering a few questions. So Ken asked a really great question about automaticity. The question is, how, if we don't have time tests, do we develop automaticity? Well, we know that time tests actually don't encourage automaticity. The fast kids stay fast, the slow kids stay slow. And that article on YouTubed does show, talk about other ways of developing mental math and automaticity. So definitely go to that as a resource for that. Dirk asked the number of people who finished the teacher MOOC. Actually, it was 40% of people got right to the end, and I think the people who are actively engaged was higher than that, because many teachers, it ended just before the school year started, just after the school year started. So I know lots of people only got through about half of it. So now's the chance to get to the other half. But yes, but still great participation rates, much higher than other MOOCs. I'm looking at other questions now. So I'm not sure how to pronounce this, Lawana perhaps, asked how the grouping strategy be adapted for very small classes or multiple grade level classes. So I think complex instruction is really great the more diverse the class is. Actually, we know it works well when classes are very different. The kids are very different, better than when they're all high or all achieving at low levels. So great if it's multi-age. It works in small classes too. Somebody says, should you jump from having students in rows to doing a 4-person group? Would it be easier to start with pairs of students? And can I do the participation quiz with pairs. I think the participation quiz would be hard with pairs. You could try it. I mean, I'm all for trying things in the classroom and seeing what happens and learning from them. You probably can get good participation happening with 2, but ideally I would go to 4 people groups, and the complex instruction book really gives you some tasks to start with that really need all 4 people. So I think you can go from rows to 4 in a group. It's amazing how good students are actually at engaging in groups, particularly if they have set roles. How do you convince, Linda's asking, how do you convince teachers to take the time to support discourse and reasoning when they're focused on how many standards and the depth to which they must teach those standards in a typical school year? So discourse and reasoning are a big part of the Common Core standards, and you probably know if you've tried some of the new tests that are coming out, they also assess discourse and reasoning, and kids can no longer be successful choosing A, B, C, or D. They have to explain their methods. So very important for their achievement. It's also extremely mathematical. It is the future that kids need. We know that the biggest growing job in the US is somebody who's a data analyst. All the new companies in the US have large amounts of data, and people need to be able to ask questions of the data and reason through different presentations they give so that other people can access. It's a very important thing. And discourse and reasoning, the cherry on the cake really, give students better access to understanding and help them achieve at higher levels. So the question about automaticity without speed drills, I mentioned going to that paper to see some. But the other thing I recommend is, if you want kids to practice on math, there's nothing wrong with practicing. Math practice is important. But I recommend they do that on engaging apps and games. We have one developed at Stanford called Was It Trouble, which is a really nice app. Motion Math is really nice. There are lots of bad math apps and games out there actually, and so I try and sort of recommend ones. In fact, in the teacher course there's a section on which apps and math apps and games are good. But that's a good way to practice, and it's much more engaging for kids. So somebody says, can you talk about math, Linda? Can you talk about math disabilities, and does having a fixed mindset have a role in that? Absolutely, it has a role in that. And I think a lot of kids, there are kids who have particular special needs, and then there are kids who've just been traumatized by math, and actually it's hard a lot of the time to separate those kids. Most kids who are achieving at low levels do have a fixed mindset, and so working on mindset with those kids has a huge impact, and it has the biggest impact on those kids. So definitely. What are the dates for the summer teacher course, and will we have access to notes for today's webinar? So the teacher course is open for registration now. The classes will officially open on June the 16th and stay open. And what we're looking into doing is having the first cohort, so it opens on June 16th, stays open until mid-September, and then maybe a second registration if people want to take it late August and go through to later in the fall, that one. But at the moment it's open. You can register now. And do so. Somebody, Andrea, can you speak about when you're the only person in your school that believes all this? How do you keep your spirits up when the structure doesn't value what you feel is critical? Yeah, I absolutely feel you, Andrea. That's a really hard situation to be in. It's always great to have colleagues. What's wonderful about the new technological age we live in is you can find those colleagues and have those colleagues through connections technologically. UCubed is going to start having a lot of teacher community on it, so I would recommend signing up there. The teacher course, the teachers stayed together. So I guess we've run out of time, but thanks very much for joining me, and yeah, we'll send out notes from this later.
Jo, thank you very much for a wonderful webinar and a more terrific course. Your commitment comes through loud and clear, and I believe that everyone will benefit from this, both parents, teachers at various levels. Thank you all for joining us, and we wish you a good day wherever you are.